So let's examine example number 1 that deals with the gravitational law. So let's begin. What is the force of gravity acting on a 4,000 kilogram spacecraft orbiting the Earth a distance of 6,380 kilometers away from the Earth's surface? And what is that spacecraft's velocity? So let's begin by drawing our diagram of our system. So here's our Earth, which by the way has a mass of 5.98 times 10 to the 24 kilograms. And here's our spacecraft orbiting our Earth in a cyclical manner, a distance 6,380 kilometers away from the Earth's surface. Now we want to find the force that this spacecraft feels due to this Earth. What is the centripetal force that this mass exerts on this object? And to find that force, to find its magnitude, we simply use our gravitational law. To find its direction, we simply note that direction always points to the center of the Earth, to the center of mass. And in this case, the center of mass coincides with the geometric mass because we're making an assumption that our Earth is in fact uniform or has uniform density. Now, we're also making the assumption that this spacecraft is a point in space. And that's because the mass of the spacecraft is much smaller than the mass of the Earth. And that's why we can make the assumption that this guy is simply a point in space. And that will become important in solving this equation. So, this equation, the gravitational law, is simply force equals G, our gravitational constant, which is simply 6.67 times 10 to the negative 11 meters cubed divided by kilograms times second squared. Now notice one thing. We're dealing with meters, and this is given in kilometers. And that means before we plug this in anywhere, we have to convert this into meters. So, to convert this into meters, we simply multiply this by 1,000 because there are 1,000 meters in a single kilometer. So, G times mass of the Earth, which is this in kilograms, times mass of the object, which is this also in kilograms, divided by the distance between the two objects' center of mass squared. So, remember, we're making the assumption that this is in fact a point mass. So, its distance from this object to this Earth's surface is simply 6,380 kilometers. But this mass is much larger than this mass, so we can't make the same assumption that this is a point mass. And that means we actually have to find our center of mass of the Earth, which is simply its geometric center, because we said this object, our Earth, has uniform density, has uniform mass density. So the radius of the Earth is 6,380 kilometers, just like this distance. So to find our actual distance, we simply multiply this guy by 2, or we add the same amount to that amount. And notice we have to convert this guy to meters as well. So, let's plug in our values into our formula. So this is the gravitational constant, this is the mass of the Earth times the mass of the object, the spacecraft, divided by the distance between the center of mass squared. So 6,380,000 multiplied by 2, or we simply add the same amount to itself. And we have to square that, and we get 9,800 newtons. So this is the force that our spacecraft feels due to the mass of the Earth. And this is also known as the centripetal force. And this centripetal force, which we're assuming is constant, creates acceleration, which is also constant. And that means it creates velocity, which must also be constant. So, now to find the magnitude of velocity, we simply use our formula F equals ma, where in this case our acceleration is simply velocity squared divided by r, as we saw in a previous lecture. So, mv squared divided by r equals f, and we simply now solve for v. So we bring the r over, we divide by m, and we take the square root, and we get that our velocity of the object, or the magnitude of velocity of the spacecraft, is equal to the square root of force times distance divided by m, where this r is simply the distance between their center of masses. This force is the force felt by the spacecraft, and this mass is the mass of our spacecraft. So we plug the values in, and we find that our velocity of the spacecraft as it's orbiting our Earth at any point in time has a magnitude of 5,591 meters per second. Its direction is always perpendicular at a 90-degree angle to the centripetal force, to the force that's pulling down on the spacecraft, which is simply this force here.